In the previous notes, we talked about proving triangles congruent with rules for side, 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 and side, angle, side. And today we're going to talk about proving triangles congruent with angle, side, angle, ASA, and angle, angle, side. So just a reminder here, we talked about included angle on the last set of notes. We're going to talk about the included side this time. And what we've got is we've got angle R in this picture, and we've got angle T in here. And what makes up the included side is the side in between those two, which is RT. And you could have said TR. It doesn't make any difference. That's what's included. So, what is angle, side, angle? It says if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. The reasoning for angle, angle, side is if two angles and any side, so I don't know if you just want to put A and Y, because we've got that A there, any side of one triangle are congruent to the corresponding two angles and any side of the second triangle, then the triangles are congruent. And in preparation, again, I put it on the previous notes, I'm putting it here again. CPCTC means corresponding parts of congruent triangles are congruent. Remember that we're talking about shortcuts now when we talk about side, 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 angle, side, angle, and angle, angle, side. We only have to prove 3, and once we prove 3, then what ultimately means is it means that all 6 of the parts are congruent, and we use this reason when proving parts of a triangle are congruent. But let's look at how angle, side, angle, and angle, angle, side work. And actually we've got one more little bit of theory before we get to that. It says, notice that side, side, angle, and angle, angle, angle do not work for triangle congruence. We're going to stick with the 4 choices that we have, at least for now. Maybe a 5th one eventually. But think back to angle, angle, angle. And if we think back to angle, 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 it says, find a counterexample to show that angle, angle, angle does not work for triangle congruence. So I'm going to leave a little bit of space to write a sentence here. But if we draw a picture, so there's one triangle, and I checked myself on space, and there's another one. And what happens here is we could say that this angle is congruent to that angle, and this angle is congruent to this angle, and this angle is congruent to this angle. But does that make the triangles congruent? And technically you're not really supposed to look at something and go, well, clearly the triangle on the left is smaller than the triangle on the right. The only thing that angle, angle, angle tells us, if you remember from a while ago, is that angle, angle, angle means that triangles are similar. It doesn't mean that they're congruent. It means that they're similar. And we can see here, based on my picture, even though it's weak at best, that they are not congruent. Now that we know that, let's look at a couple of examples and see if we can identify. Don't forget that we still have side, 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 and side, angle, side as options. We are focusing more so on the angle, side, angle, and the angle, angle, side today. But if we look back on letter A, determine which postulate, if any, can be used to prove that the triangles are congruent. So we've got triangle YTN and triangle WSJ. And if we look at the triangle to the left, YTN, what we've got is we've got one tick mark there at angle Y, and we've got two tick marks here at angle T, and we've got the included side there. In comparison, we still have one angle here and two angles there, but the side JS is not included, and because one of the sides is an included side, the other one is not an included side, these triangles are not congruent. If we look at letter B, a bow tie example, something that we know about bow tie triangles is that vertical angles are congruent. Going to try to mark that up one more time. Vertical angles are congruent in there. And now what we see is that we've got one angle in one triangle congruent to one angle in another. We have our vertical angle marks there for congruency. And then we also have sides. An angle, angle, side is an option. The sides do not have to be included. So this one's going to be angle, angle, side. Letter C, there's lots of options. This is a shared side triangle, but we can get our answer based on the information that's given to us already. There actually are more than one answer on this one, but if we look specifically here, we've got angle A, and we've got angle DBA, and the included side on this kind of bottom triangle. In our other triangle, we've got angle E, we've got angle BDE, and its included side. And this one, we can say angle, side, angle. There's other options on that one. But lastly, when we look at letter D, we've got the right angle in both of the triangles. We've got a 2 tick mark angle in both of the triangles, and we have a 3 tick mark angle in each of the angles. But we have angle, angle, angle. And although they appear to be congruent, angle, angle, angle does not prove congruency. It only proves similarity, and we're trying to prove congruent. So this one is not congruent. Flipping our paper over, let's look at a couple of proofs. And what a surprise, we have a bow tie triangle. Very commonly asked question. And then our next proof, we have a shared side triangle. But we'll stick with the bow tie here. And let's write down what we know, which is that L is the midpoint of WE, along with the fact that WR is parallel to ED. And we know the reason. It's given. Again, just a reminder, even though you may or may not be able to do this entire proof, there's no reason that you shouldn't write that down. Along with what we're trying to prove. Triangle WRL is congruent to triangle EDL. And we don't know the reason. But a couple of things here on this one. Let's start with the fact that L is the midpoint of WE. So one of the things that we see about the word midpoint is that it's a vocab word. And one of our reasons, therefore, is going to be definition of midpoint. We actually can get another reason on here as well, because bow tie triangles, somewhere in here, we're going to have vertical angles are congruent. And we don't have the whole proof filled in, but we've got parts of it. In fact, we have filled in 1, 2, 3, 4, 5 boxes, and we have 5 to still fill in. We have half of that proof done. So that's good news. Let's go back and look at definition of midpoint. And here is our point right there. It says L is the midpoint of WE. We already have the reason, so let's put in the statement. And what we know is that WL is congruent to EL because that is the definition of midpoint. L is right there in the middle of that, so we can say WL is congruent to EL. And I think technically I should be putting segment statements on there. Luckily it'll be a drop down box or a drag and drop box, so that'll already be in there for you. So we've got that marked up. The next one says vertical angles are congruent. Well, let's go back into the proof then, and let's identify the vertical angles. Here and here are our vertical angles. They're kind of opposite angles. And then what we can do is we can name that angle. Watch out, because the order is going to be important as we get closer to finishing this. But the way I named it is I did WLR, angle WLR. So that was a 1 tick mark, and then an angle, then a no tick mark. In our other triangle then, I need to do ELD, because it's 1 tick mark, 1 angle, and then no tick mark. And we already have the reason. There's a place where we've got vertical angles. So we're getting close now, but we need to come up with our last statement and reason. And there was one more part to the given. And that one more part to the given is that WR is parallel to ED. So we need to make a statement about that. And what we can do is we can draw in, so it's kind of going to be a backwards Z, I think. It's kind of a, maybe you can see that. And you don't have to draw it in this way. You could draw it in as a regular Z as well. But however you draw it in is going to determine, I said this angle here is congruent to this angle here, but it's based on parallel lines. And what we know about parallel lines is that alternate interior angles are congruent. So if we go back there, again, we need to be careful with our naming of this. But I did RWL. So we had no mark on RW, but we had one mark on the WL. So over here on the other side, I'm going to do DEL. And I need to stop back and just make sure that I got that okay. RWL, yes. DEL, yes. Gives us the alternate interior angles are congruent. And now as we take a look at this one to finish, what we see is we see that we've got an angle, we've got a side, and we've got an angle in one triangle. Then we have an angle and a side, included side as a matter of fact, and then another angle. So our reasoning on this one is angle, side, angle. So there's our bow tie, a very popularly asked question in a standardized test. As we get close to finishing, we're going to complete the following two-column proof. We've got the statements down here and possible reasons. And then we have some of it filled in for us. And in fact, as I glance at this, you see this is a shared side triangle. One of the reasons in this problem says reflexive property. And remember, reflexive is like reflection. When you look in the mirror, you see yourself. So let's look at what is given up here, and that is that GE there is the shared side. And I put a little mark on there. If we already have the reason, do we have any statements in our possible statements about that? And we do, right here. That GE is congruent to itself. GE looks in the mirror and it sees GE. Now we have more than half of the proof filled in just from writing one step down. Our given was already done for us, and let's go back and mark up our triangle to finish this. Nice thing is that angle D is congruent to angle F is already there for us. And then we've got GE bisects angle DEF. Well, there is a vocab word, bisects. Vocab word. If we look down in our possible reasons, do we have any statement about bisects? And what we see is that we have definition of angle bisector. So we've got that filled in now. And as we take a look at this one, what that means for us is that this angle here is going to be congruent to that angle there. So I'm going to start with angle DEG, I believe, and I'll look down below. Angle DEG is congruent. And actually I can see it right there, angle DEG. Is it congruent to angle FEG? And we've got it marked up. Angle FEG. And now we have everything that we need. In fact, I can really separate these a little bit, but what we've got is we've got an angle that's marked for us, then we've got the blue angle, and then we've got the green side. Again, the side does not have to be included, and it isn't, but that tells us our reason. We've got 1, 2, 3, 4, even 5 choices here, but the one that we know is we know an angle, and we know an angle, and we know a side.